Good afternoon. It is 2:20 in Philadelphia, and welcome again to Thermal Live 2016. I'm Graham Kilshaw with Electronics Cooling Magazine, and we are the creators of Thermal Live. This presentation is Aerospace Electronics Simulation, brought to you this afternoon by 6SigmaET. And our presenter this afternoon is Anant Sridhar, who is an applications engineer for 6 Sigma, and he's based in San Jose, California. Good afternoon, Anant. How are you today?
I'm good, Graham. Thank you. How are you?
Great. We're also joined by the senior technical editor for Electronics Cooling Magazine, MP Divakar, who is also in San Jose. Good afternoon again, MP. It's good to have you back.
Sure. Good morning or good afternoon or good evening. I know we have a global audience all over, so it's great to join. It's been a wonderful day so far, and I'm looking forward to some exciting things, from 6SigmaET.
Yep, this is a product demonstration webinar this afternoon. So Anant is going to walk us through how the 6 Sigma software and simulation works. But before we begin, in case you have not attended Thermal Live before, a couple of quick pointers to the attendees on how to get the most out of the platform. If you want to ask a question, please use the Q&A button at the bottom of the screen. If you have any technical issues, please go to the yellow tab on your screen. If you'd like to chat with other people who are attending live from around the world, you can use the group chat button at the bottom of your screen. You'll also see 2 links at the bottom of your screen. The first one takes you to the Thermal Live website. You can still register for presentations that happened yesterday and the remaining ones today. And the second link will take you to the 6 Sigma website, where you can learn more about this product. The slides will be available in 24 to 48 hours with copies of Anant's presentation. And a video recording of this presentation will be available in a couple of hours from now. So you'll have those very quickly. Okay. And with that, this presentation is going to last 15 to 20 minutes, and then Anant and MP will field your questions. So send in your questions at any time during the presentation. And with that, I'm going to hand over to Anant. Anant, shall we begin?
Thank you, Graham, for that. Hello, everyone. This is Anant here. I work as an applications engineer at Future Facilities. Future Facilities was founded in 2004 with a mission to establish engineering simulation as a standard and unifying platform for the data center ecosystem. 5 years later, we tuned our technology to deliver the same benefits for the thermal management of electronics. And to that end, we have built a suite of CFD software capable of doing analysis at the chip and the board level, scaling all the way up to the external modeling, design, and operational planning of data centers. My colleagues are part of important committees and lead the efforts at various consortiums, including GreenGrid, ASHRAE, and Semitherm. Now, we define 6 Sigma ET by 4 metrics. The software is designed to seamlessly integrate with objects knowing what they are and how to behave, all while making most of the repeated tasks in a CFD analysis automatic with a proprietary powerful solver. We'll see all those in detail in the demo later. These are some of the examples previously modeled in 6 Sigma ET. As in 6 Sigma's ET's intelligence is expanded to a broad range of applications, from an LED bulb on the top left to an outdoor box model using solar radiations on the bottom right. Next, we'll see the demo of 6 Sigma ET using an air transport rack, a case study that we carried out in partnership with Tech LLC Engineering Services. Thank you for watching the video and joining us today. For more information on 6SigmaET, you can send us an email directly on info@futurefacilities.com. And for more information on Tentech LLC's engineering services, you can contact wwillers@tentechllc.com. Thank you again.
Thank you, Anand. This is MP Divakar, the technical editor of electronics cooling. Interesting presentation. I do like the ease of use, and I think some of the solution statistics are pretty impressive too. The 80 million equations, 80 million grid cells you just mentioned, with 60 cores. I was just curious, what was the RAM that was available for that solution? Memory. Excuse me.
The RAM for that machine, I think it was about 64 GB.
Okay.
Yeah.
I was just curious, just as a solution point. So we have a question from BT from Santa Clara University. Can we do transient simulation with your software tool?
Yeah, we can run transient simulations in our software, and similarly, like the steady state, it's easy to set up and easy to run and analyze the results as well.
Okay. What percentage of your users typically end up doing transient as opposed to steady state?
It's really hard to comment on that about our customer base because we really don't get to know, but I would say a good percentage of people use transient analysis on our software.
And, with respect to the electronics cooling community, the board assembly example you were showing that was pretty interesting. Do you make the user's job any easier, with some standard library components that they can pull up and place?
Yeah, there are a set of components in our library that users can take advantage of. And besides, our library is a shared library, is a very powerful library that users can share between different users within the same company, and it's very easy to use.
Okay. With a typical installation, what are the requirements? Does this run in a standalone license, or is it a cloud-based license, or how does that work?
We have all types of licensing. It can be either standalone, a node lock license, or it can be a floating license. And our floating license are globally shared, so we don't restrict based on the geographic location of where the server is.
Okay, and then I don't see many more questions coming in. I have a couple more. With respect to your solution, do you have any feature that basically takes the grid and exchanges that, for structural mechanical simulations? How can the users take the results from thermal simulation into thermomechanical?
There are multiple ways to export the results from 6SigmaET through a CSV file that they can use as inputs for their boundary conditions in an FEA software. But there is no direct integration with any FEA tool, so to say.
Okay. Regarding the geometry, what input formats especially the CAD input, does 6SigmaET support?
We support STL files for CAD input. But we have a add-on called 6Sigma Geometry, using which you can export. You can import any file format that you want and export STL out of it.
Okay. That is just about all I had. Let me pause some more, see if there's any more user questions. I don't see any. Do you have any closing comments? Maybe a few words about your future plans and product development, what is coming down the pipeline next year and the year after?
Yeah, sure. Our product development lifecycle, good that you brought that up. It's pretty quick. We have at least 2 releases every year, and we have another release coming up this December, and we keep updating our tool with Power Pack features. And our development is, again, it's customer-centric development. We cater to the needs of the industry and our customers. And also, we offer free trials for those who want to try 6SigmaET. They can just log on to our website, www.futurefacilities.com, and request a free trial of a tool.
Okay, we have a couple more. I think we have 2 more minutes before I have to wrap up. Moshtaba, I think, I hope I didn't kill his name. Does the software allow modeling the PCB copper traces? And on the same breath, do you take care of the joule heating effects in the traces?
Yeah, we allow copper traces to be explicitly modeled in our software. We do a Gerber import, which is a standard input for trace information. And another good feature about our software is when you do a Gerber import and you import the trace information, it can be computationally intensive to model each traces explicitly. So we have an inbuilt image processing which processes the image and it maps the copper information to the grid and assigns the copper percentage accordingly, which is a really nice tool to have. So you get the accuracy of modeling the traces, but you're not explicitly modeling it, and it's computationally less intensive. And joule heating, yes, we do joule heating in our tool.
Okay.
That question, yeah.
Right, and I think it's your colleague, someone who has made a comment that there are some features that were not shown today, especially liquid cooling and other features. I know we have a very short time for this, so with that, I think I have to wrap up. Thank you, Anant, and the Future Facilities team, for taking your time to present at the Thermal Live event and address some of the, I would say, the challenges and the concerns of thermal management engineers and professionals. It's been a great day so far. Thank you to our audience. I know we have a global presence. We've had audience from all over, from all time zones. Some of them, in the middle of the night, or late in the night, or early in the morning, whichever way you look at it. Again, that goes to show you the attraction and also the value add that electronics cooling brings to the thermal management professionals. The recording will be available in about an hour or 2 of the session. The slides, if any, we will be sharing. I think there are slides in this that we'll share. That will take about 24 to 48 hours. For all of those who registered, you will get an automatic email update. And to those of you in the audience that did not register for all of the sessions, it's not too late. You can register for yesterday's and today's. We'll get a link. You'll get a link to all the presentations if you do so. With that, again, thank Future Facilities and 6SigmaET for bringing this presentation to Thermal Live. Have a great day, guys. Thank you. Bye.
Thank you, everyone. Bye.